Coders, in this video we will see the next question from our LeetCode 75 list, and let me take you the screen first. And yeah, here this is the question, which is guess the number higher or lower. Okay, so what question says, we are playing a guess game. The game is as follows: I pick a number from 1 to n. You have to guess which number I picked. Okay, every time you guess wrong, I will tell you whether the number I picked is higher or lower than your guess. You can call a predefined API. The API is basically a guess int or number. So here, the API is basically a function that we call, and that will return a -1 if that number which we are sending that API, basically that we are calling a function and we are sending the uh, number that we just picked, and basically we are guessing a correct number. And if a number that we are sending is higher than the number I like the number which a system has picked is higher than what we have picked, then it will return -1. If it is lower, then it will return 1, and if it is equal, then it will return 0, and return the number that I picked. Okay, so here I picked is basically means the system which number has picked, that we need to return. So yeah, how we can solve this? As it is giving that higher, lower, equal, such things, uh, this things gives intuition of binary search. What happens in binary search, that we take a lowest limit and we take the highest limit, we add up, then we take the middle one, that l plus r by 2, likewise, or l plus r minus l by 2, both give the same, then we take the middle one, and according to that, if the middle one is higher, okay, if it is higher, then I don't need to find a number from from in next hop. It must be in first hop, because the middle number itself was higher. If it is lower, then I have to pick from the second half, because the middle number itself was the lowest. So likewise, we divide our search space in by 2 by basically, and likewise we find the number that the system picked, and we are dividing the search space by 2, so it is a binary search. Okay, there are other things also, like a ternary search and everything, but right now we have to solve it using binary search. And yeah, we'll code it. Let me take the screen again, and here. So yeah, let's take a number which is, it can be 0, and like minimum number can be 0, so I will say कि my lowest guess can be 0 and my highest guess can be n, cause that's what they'll give. uh, n is equal to n. Basically I pick number from 1 to n. Okay, from 1 to n, so basically lowest can be 1 and highest can be n. So while my lowest is less, so this is basically syntax of binary search. While the lowest is less than highest, what I will do, I will take a number which is middle one. The middle one basically low plus high, low plus high by 2. But what we will do here, we will not use this, cause sometimes what happens ki low plus high will can exceed the int, like it can't fit in int low plus high. So what we will do ki I will just this low plus high minus low by 2. So this is same as low plus high. How? Let's see here. What first was like the high plus low by 2. Okay, so this is how we find middle, but this is how we reconstructed it, that low plus high minus low by 2. So if we just do like this, low plus high by 2 and minus low by 2, basically I'm like I just separated the divider, and this low by 2 we can subtract it from low, and this, but this will be then low by 2, and low by 2 plus high by 2 remains, like we just subtracted this, so this remains. Then what happens ki base are same, so we can add numerator and low plus high by 2, the same thing we got. So yeah, so this formula works. Mid is equals to low plus high minus low by 2. And what we will say ki if the gates, okay, we'll store that gates in g is equals to guess this mid number, and if my g is equals to minus 1, that basically if when this will be the minus 1 when the gauge is higher than the number I picked. So the gauge is higher, that mid is higher, basically that what it is saying. If mid is higher than the number that system has picked, then we have to reduce our search space to the first step. So high is equals to mid minus 1. Okay, else if my g is equals to 1, so that it means my guess is lower than the number I picked. So basically we need to see in second half, so we need to uh, update our low value to mid plus 1, and else we need to return mid because it means ki we guess the correct number. Okay, and if we don't find anything, okay, there will not be such case happen because it gonna be choose from 1 to n only. So what we will do here, I will just say ki our result is equals to, I'll say just 1 right now, and as I'll get the result I will update it, result is equals to mid, and then I'll break and then I'll return the result, run it and submit it. So yeah, it got accepted. And what the time complexity for this, as we are every time we are doing half our search space, so the time complexity for this will be big of log n, here log n base 2, and space complexity is constant, that we have used just what low, high and raise, so space complexity is big of 1. So yeah, that was today's question. If you like the video, then like, share and subscribe to my channel. We'll meet in next video. Till then, bye bye.